Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0098, indicates a high voltage condition in the intake air temperature IAT sensor 2 circuit of the Honda CRV models from 2017 to 2022. This specific code is crucial as it can affect the performance and efficiency of the vehicle's engine management system. The IAT sensor measures the temperature of the incoming air, which is essential for the vehicle's engine control unit, ECU, to optimize fuel injection and ignition timing. If the sensor fails or the circuit exhibits high voltage levels, it can lead to incorrect readings, resulting in poor engine performance, increased emissions, and potential engine damage over time. The following slides will cover a detailed description of the error, possible causes, symptoms, and step-by-step troubleshooting processes based on the provided diagnostic information. The IAT Sensor 2 is a critical component located within the air intake system of the Honda CRV. It measures the temperature of the air entering the engine to provide real-time data to the Engine Control Module, ECM. This sensor is crucial for determining the correct air-fuel mixture, which directly impacts engine performance and efficiency. If this sensor is malfunctioning, it sends erroneous data, leading to performance issues, emissions problems, and potentially engine damage due to improper fuel mixtures. Ensuring that this sensor operates correctly is vital for the overall health of the vehicle. Incorrect readings can cause the engine to run lean or rich, negatively affecting fuel efficiency and performance. The possible causes for DTC P0098 are primarily centered around three main areas. First, the circuit connected to the IAT Sensor 2 may be experiencing high voltage, indicating an electrical issue or a short circuit. Second, the IAT Sensor 2 itself may be defective, leading to inaccurate voltage readings. Third, wiring issues such as bad connections, frayed wires, or poor insulation can lead to unexpected voltage levels. Each of these potential faults needs to be systematically diagnosed to pinpoint the root cause. By checking the circuit's condition and the sensor's functionality, one can identify whether the problem lies within the sensor itself or the surrounding wiring. Symptoms associated with DTC P0098 can manifest through various performance issues in the vehicle. First, drivers might notice poor engine performance, including lack of power during acceleration or rough idling. Unusual fuel consumption can be another indicator, where the vehicle may start consuming more fuel than normal, leading to increased operational costs. The check engine light will typically illuminate on the dashboard, indicating that there are issues to be addressed. Additionally, one might experience fluctuations in engine temperature readings, which can further affect the vehicle's overall efficiency. Awareness of these symptoms is essential for early diagnosis and repair. The first troubleshooting step involves confirming the fault by observing the vehicle's behavior in on mode. Start by turning the ignition to the on position, ensuring that all electrical systems are activated, but the engine is not running. Using the Honda Diagnostic System, HDS, check the voltage level from the IAT Sensor 2. The expected voltage should be above 4.92 volts. If this threshold is met, the failure can be confirmed, and you would proceed to the next step in the diagnostic process. However, if the voltage does not exceed this value, it indicates an intermittent failure. In that case, check for poor connections or loose terminals at both the IAT Sensor 2 and the Powertrain Control Module, PCM, to ensure the integrity of the circuit. In this step, you'll begin by turning the vehicle to the off position. Carefully disconnect the 2P connector from IAT Sensor 2. To conduct a continuity test, Use a jumper wire to connect Terminal A and Terminal B on the 2P connector. After establishing this temporary connection, turn the vehicle back to the on position without starting the engine. Next, use the HDS to check the voltage again. The voltage should still be more than 4.92 volts. This step helps determine if the issue lies within the sensor itself or if the wiring to the PCM is the root cause. If the voltage condition matches, proceed to the next troubleshooting step. Otherwise, consider replacing IAT sensor 2. Following step 2, turn the vehicle off again and remove the jumper wire from the IAT sensor 2 connector. Reconnect the IAT sensor and then switch the vehicle to on mode. Using a multimeter, you will need to measure the voltage between test points 1 and 2. Test point 1 is the first female terminal of the IAT sensor connector, while test point 2 is the body ground. The expected reading should be around 5.0 volts. If this voltage is present, the ITA2 INTA line circuit is likely intact, and you can proceed to the next step in the troubleshooting process. If the reading is not close to this value, further investigation into the wiring or connections is necessary. This step is focused on checking for open wires in the SG2 line. Start by turning the vehicle to the off lock mode. Jump the SCS line using HDS and wait for more than 1 minute to let the system reset. Then, disconnect the PCM connector E, which has 80 pins. Check for continuity between the second female terminal of the IAT sensor 2 connector and pin 78 of the PCM connector E. This continuity check ensures that the SG2 circuit is intact. If continuity is confirmed, the wire is functioning correctly. You may then refer to any authorized service information related to DTCs for further guidance. If continuity is absent, it indicates an open in the SG2 wire requiring repair. In the final troubleshooting step, once again, turn the vehicle to the off mode. Repeat the process of jumping the SCS line with the HDS, waiting over 1 minute. Next, disconnect the PCM connector E, similar to the previous step. This time, check the continuity between the first female terminal of the IAT sensor 2 connector and pin 55 of the PCM connector E. Ensure the expected reading indicates continuity. If so, the ITA2 INTA wire is functioning correctly, indicating that the issue may not lie within the sensor circuit. If continuity is not confirmed, then an open circuit in the ITA2 wire must be repaired for optimal functioning of the IAT sensor. After addressing potential faults and making necessary repairs, it is crucial to conduct a final verification test. Begin by taking the vehicle for a test drive under various conditions to observe its performance closely. Monitor engine response, acceleration, and engine temperature readings, ensuring they align with normal operating parameters. After the drive, recheck for any recurring diagnostic trouble codes, DTCs, using the HDS. If DTC P0098 does not reappear, it's a positive indication that the repairs were effective. Additionally, check that the IAT sensor 2 functions correctly and that all previous symptoms have been resolved. To prevent the occurrence of DTC P0098 and ensure the longevity of IAT sensors, implement a regular maintenance routine. Start with periodic checks on all electrical connections and terminals associated with the IAT sensor and PCM. Corrosion or dirt buildup at connections can lead to voltage fluctuations. Additionally, keeping the sensor clean from debris and contaminants is vital for accurate readings. Lastly, Ensure that the vehicle's software is up to date, as manufacturers occasionally release updates to enhance sensor function and performance. Adopting these preventive maintenance strategies can significantly reduce the likelihood of sensor failures and related faults. In conclusion, understanding and addressing DTC P0098 is essential for maintaining optimal vehicle performance. This code specifically highlights issues with the IAT Sensor 2 circuit, which is vital for accurate engine air intake readings. By systematically following the outlined troubleshooting steps, technicians can effectively diagnose and repair faults, ensuring the sensor operates correctly. Additionally, adopting regular preventive maintenance practices will help avoid potential issues related to sensor function in the future. Ultimately, addressing this DTC promptly can lead to enhanced engine efficiency, reduced emissions, and improved overall vehicle performance. Please like and subscribe to the channel. See you next time.